Today we're going to talk about domain and range, so please make sure that you have your heading on your paper and you can pause this video at any time. We're going to start off with the definition of domain and range. So the first one we're going to talk about is domain. So you want to make sure you fill these in. You're going to show me your notes by sending me a pic when you are done to get credit, and you send it in Canvas. So the domain is the set of all input values. And that is just your x's. So I'm going to put x's in the front. Your range is the next one. So can you write range for me? Your range is the set of all output values. The set of all output values. I'm just making this a little less blurry, hopefully. And your range would be your y's. So now we're going to talk about the ways that you can have domain and range listed. So can you write 3 ways to list domain and range? So we're going to talk about those 3 ways today. So the first way is going to be roster form. So for number 1, can you write roster form? And I'll give you what that means, and then we're going to come up with the definition. So roster, we're going to come up with an example, I'm sorry. So roster form means listing the set. So we'll put listing the values in a set. Listing the values in a set. So here's an example. I'm going to put a little star here so you can see the difference between the ways and the examples. So can you write f of n equals 2n plus 1. List the range. List the range. If the domain is, and I'm going to put in little brackets. These are little squiggly brackets if you can't make those. I'm going to put -3, 0, and 5. So what we're going to do to figure out the range will be our y values, our f of n values. So what we're going to do is plug these numbers in place of n to get our y, our f of n's. So we're going to find f of -3. We're going to find f of 0. And we're going to find f of 5. Once we do that, that's going to give us our y values, and we're going to list them like the domain is listed here. So for f of -3, I'm just going to change the n to -3. So 2 times -3 plus 1. To find f of 0, I'm going to do 2 times 0 plus 1. To find f of 5, I'm going to do 2 times 5 plus 1. And we're going to figure these out. So 2 times -3 plus 1 is -5. I won't bark, I forgot to close the windows. 2 times 0 is 0 plus 1 is 1. And 2 times 5 is 10 plus 1, that's 11. So the range in roster form would be these 3 numbers in order in a set like this. So we're going to put little squiggly brackets, and we're going to list the numbers, -5, 1, and 11. That is roster form, where you just list the set. The second way is going to be interval notation. So let me move this up a little bit. So the second way is interval notation. That's where you list the first and last values. So can you write list first and last number, I put the number symbol, with either parentheses or these little rectangular brackets. And I'm going to explain what those are. So if we're listing a domain and range this time, if we list it in interval notation, we'll have parentheses around the numbers or brackets. This is what they mean. If you have parentheses around the number, that means the number is not included. So can you write number is not included? And I'll give you an example. Number is not included. If we have brackets next to the numbers, so these are not squiggly brackets, that means the number is included. So what I'm going to have to do is turn over my paper, and we're going to do an example, and I'm going to show you a little graph, which you can just make a sketch of. So I'm going to go to the back of my notes, and here's my example. So I'm going to put a little star. If you have room, you can do a star as well. I want you to do me a favor and make a little graph for me. We're going to make just a box that has a graph in it with a little X and Y axis. And this is what I want you to graph. Now, I don't want it to, we're going to look at this on the note, so all I want you to do is just make a sketch of it. So I'm going to use a different color, and I'm just going to have it look very similar to this, so it doesn't have to be perfect. So can you just make that sketch for me? Now what we're going to do is find the min and the max of the x's and y's. So I'm going to just cover this up for now, but this is what you have on your notes, just so you know where this came from. I'm going to have us write on the side x min equals and x max equals. What that means is your highest and your lowest x value. So if you look at our graph, these are our x's. The furthest that this graph goes to is this number, which is -3. So I'm going to put -3 for my smallest x value. This graph goes all the way to this side, goes all the way to this x value. This x value is 6. If you count your numbers, 1, 2, 3, 4, 5, 6. So I'm going to put 6 here. We're going to do the same thing for our y's. So can you write y min and y max? The reason why I'm doing this is because we need to know the first and last numbers. So we need to know the highest and the lowest number in order to write it in interval notation. So my y's, the lowest point would be this right here. That would be at -5, counting down. So we're going to put -5 here. And our highest that this curve reaches is right here. And if we go up, that would be 3. So we're going to put 3 here. So now what we're going to do is we're going to list our domain and range in interval notation. So can you write domain for me? Since there were dots at the end of these points, there were closed dots, we are going to include these numbers. So our domain is our x values. It went from -3 to 6. So it started all the way over here and went to +6. So we're going to put -3 and 6 next to each other. And because they are included with closed points, we're going to put brackets around it. Our range would be our y values. The y values would be from the lowest to highest y. Well, our lowest is -5. Our highest was 3. Again, because these were closed dots, we're going to have brackets around them. If either of these were open circles, then we would have parentheses next to the numbers. The last form we're going to talk about today is set builder notation. So can you write number 3, set builder notation? And I'll move this up. So set builder notation. So these are the 3 ways to represent the domain and range. Domain is your x, range is your y. Let me get the dog. That was quicker than I thought. All right, so set builder notation, that's where you list the answer as an inequality. So list the numbers as an inequality. So we're going to be using our less thans or our greater than values. So they could look like this. I'm just going to put a little example here so you can see what I'm referring to. Can you put EX for me? So an example of set builder notation would be something like this. I'm going to leave a little bit of space. X is less than 5. But unfortunately, we have to put brackets around it, and we have to put this X with a little bar here or a colon. That would be set builder notation. You state the letter you're using and you have the inequality next to it. Here's another example. We could have an inequality like this. -3 is less than or equal to Y is less than 7. That means your range, because it's Y's, go from -3 to 7, including the -3 because there's a line. But again, we need brackets and we need that Y in the front to talk about what it is. So this is what set builder notation looks like. This one's the most confusing because you have to remember all this extra stuff. So if we look at our example up top, so what I'm going to do is draw a little arrow here. This comes from these numbers. I'm going to rewrite my domain and range based on these numbers. So if you write domain, and again, we'll spend more time on this. This isn't the only time we're doing it. Our domain is our X values, and it goes from -3 to 6, and it includes both. So I'm going to make it look like this with an X. So I start with -3. It's included, so I put less than or equal to. My domain is my X's, and it's less than or equal to 6. That means that we are going from -3 to 6. That's your domain, but I can't forget that extra stuff. I need squiggly lines around it, my brackets, and I need the letter I'm representing, which is my X in the front. My range, let's do the range the same way. My range goes from -5 to 3. So I'm going to do the exact same thing here, but use different numbers, and I'm using a Y because my range is the Y. So I'm going from -5 to 3, so -5 is less than or equal to Y is less than or equal to 3. Now I need that extra stuff around it. I need my little brackets, and because I'm talking about a Y, that needs to go in front to show that that's what it's being represented as. Just a couple more notes and then we're done. I know these are quite long for notes. Just want to point out sometimes we can't have a domain. So can you put a note for me, right? N-O-T-E. So we're going to say values that cannot be in a domain, of a function. And I'm going to give you a couple of them. So one of them would be, there's two that I'm thinking of right away. So functions that are undefined. Functions that are undefined. What does that mean? That means you have a bottom on the 0. You have a 0 on the bottom of your fraction. So you could put something like denominator equals 0. You can never use an X value in a function that has an X on the bottom, or that has 0 on the bottom. Another function that cannot have a certain number in the domain, when you have a square root. Do you know what number you cannot have under a square root symbol? You cannot have a negative number. So can you write square root of a negative number? Square root of a negative number, and I abbreviated that. So that means the number has to be greater than or equal to 0. So I just added that at the end. So I wanted to mention this. You do not have to write this example. I just wanted to show you. I'm going to take this off and show you for instance. If I gave you this function, you do not need to write this unless you want to. This is an example. This is just extra. If you have y, this is an example, y equals the square root of x plus 4. What can't you have in the domain? So I'm just going to write this, and again, you don't have to put this, not in the domain. Well, we just talked about if we have a square root, you can't have a negative number. So whatever is in here has to be greater than or equal to 0. So if I gave you these numbers, 0, 5, -3, -8. If these numbers are not in the domain, that means we would get a negative number. So if I plug in 0, the square root of 0 plus 4, you don't have to write this again. That gives me the square root of 4, which is 2, so that works. If I plug in 5, the square root of 5 plus 4, that's the square root of 9, which gives me 3. That works. If I plug in -3, we have the square root of -3 plus 4. Well, that's the square root of 1, and that would be 1, so that's okay. But let me try the last one. The square root of -8 plus 4. If I plug that in, -8 plus 4, that is the square root of -4. I cannot have the square root of a negative number, so this is the number that's not in the domain. So you do not need to copy this part down unless you want to. Please don't forget to take a picture of this and upload it into Canvas in this assignment.